When 3I/ATLS passed by Mars on October 3, 2025, scientists got their first close look at something truly alien, an object not born in our solar system, but one that arrived from the deep void between stars. Captured by NASA's Mars Reconnaissance Orbiter, ESA's Mars Express, and even the Perseverance rover, its brief encounter with the red planet marked the start of an extraordinary scientific window. What sets this comet apart isn't just its path, it's the possibility that its icy core contains molecules forged in ancient foreign star systems. As it approaches the Sun, there's a chance it will flare, disintegrate, or unveil materials completely unfamiliar to Earth-bound science. If you're still watching, subscribe now. You crave more than answers. You seek what lies beyond. Subscribe now and be part of the few who never stop searching. That's why all eyes are turning toward its next destination, Jupiter. When it nears the gas giant in March 2026, the stakes rise dramatically. At a distance of 54 million kilometers, Jupiter's immense gravity could pull 3I/ATLS apart, nudge it onto a new path, or allow it to slip by intact. Each scenario offers a rare scientific opportunity to study how interstellar bodies react to massive gravitational forces, to analyze their structural integrity, and to glimpse the kinds of matter that formed around distant stars. This is not just another comet flyby. It's a one-time chance to witness the behavior of a visitor from another star system, and to collect data that could reshape our understanding of how planets, stars, and perhaps even life itself begin. It came out of nowhere, not from the Kuiper Belt, not from the Oort cloud, not from some distant long-forgotten corner of our own solar system. No, 3I/ATLS was born far beyond the Sun's reach. Its orbit isn't elliptical like the comets we know, it's hyperbolic. That single fact changes everything. It means this thing didn't originate here. It means it's not part of us. It's a stranger, an intruder, a messenger from another star system, and it's moving fast. It swept past Mars on October 3, 2025, closer than most of us ever will be, and every major eye in the sky caught a glimpse. NASA's Mars Reconnaissance Orbiter locked onto it. ESA's Mars Express took readings. Even Perseverance, parked on the Martian surface, aimed its instruments skyward. What they saw confirmed the obvious. This is no ordinary comet. It's older than Earth. Its ices may have been frozen before our Sun even existed, before the planets had formed, before the word solar system meant anything at all. This is material forged in an entirely different stellar nursery, maybe even around a different kind of star. And now it's here, gliding silently through our system, dropping secrets behind it, like cosmic breadcrumbs. And it's not done yet. 3I/ATLS is getting closer to the Sun, heading for its perihelion, its closest approach, later this year. As the sunlight intensifies, things could get unpredictable. It might flare, brighten, unleash ancient gases, or it might disintegrate entirely, its fragile structure finally giving out after billions of years in the void. And if it holds together, it heads straight for Jupiter, March 2026. That's when it gets interesting. That's when it gets dangerous. That's when it gets dangerous. Jupiter isn't just a planet, it's a gatekeeper. Its gravity is a cosmic wrecking ball, a force of nature capable of tearing lesser objects to shreds. It's been doing that for billions of years, intercepting wayward comets, redirecting asteroids, clearing the solar system of threats. Now 3I/ATLS is entering its gravitational zone. 54 million kilometers away might sound like a lot, but in interplanetary terms, it's close. Close enough for Jupiter to flex its influence, close enough to change everything. It could shred the comet, it could twist its trajectory and fling it into a new path, altering its course in ways we can't fully predict. Or it could do nothing. It might pass harmlessly, slipping through the giant's grasp like a ghost, and then vanish forever into interstellar space. Whatever happens, it's a one-time event. Once it leaves, it's not coming back. That's the thing about a hyperbolic orbit. There is no return path, no elliptical swing that might one day bring it home. This object has crossed our cosmic fence line for the first and last time. After its flyby with Jupiter, it will be gone, forever. That's why every available resource is being thrown at this thing, because the stakes couldn't be higher. In November 2025, the European Space Agency's JUICE spacecraft, originally designed to study Jupiter's moons, will take a break from its mission and zero in on 3I/ATLS. From its vantage point, it has a unique opportunity, not just to snap photos, but to scan it, to analyze it, to catch the comet's chemical fingerprint, and maybe, just maybe, detect molecules that don't even exist in our own solar system. That's not science fiction, that's the entire point. These ices have been locked away for possibly billions of years, preserved in interstellar deep freeze. They may contain exotic compounds, unknown isotopes, or molecular arrangements we've never encountered before, material not shaped by our sun, or our planets, material shaped by alien stars. This isn't just a curiosity, it's a revelation. Every molecule detected, every emission spectrum recorded, every shift in light, it all becomes part of a growing database that might answer questions bigger than we're prepared for. How did star systems form? What's the baseline chemistry of the galaxy? How rare or common are Earth-like conditions? And maybe, in the quietest corners of the data, something else. Something that hints at life's building blocks, originating not from Earth, not from Mars, not from the solar system at all, but from somewhere out there. That's why the Mars flyby mattered. That's why JUICE's role matters. That's why Jupiter's gravitational encounter could define the entire mission, because we don't get many of these. Before 3I/ATLS, there was Oumuamua, and before that, nothing confirmed. These objects are rare, spotted only when they're already tearing through the solar system. No second chances, no time to reroute probes or launch missions, only brief, frantic observation windows and then silence. So when one shows up, you go all in. Every sensor, every agency, every frequency band, and this time we're ready. 3I/ATLS has already changed how we think about interstellar matter, and it's not even finished with us yet. Its upcoming perihelion will be a critical stress test. Will the solar heat crack its surface? Will it eject jets of vapor and dust, illuminating its internal makeup? Or will it break apart entirely, fragmenting into useless debris before it even reaches Jupiter? There's no precedent here, no textbook outcome. We've never seen anything like this. Even its behavior defies solar system norms. Its speed, its angle of entry, its chemical profile, everything about it screams alien, not in a sci-fi sense, but in the most literal astronomical meaning of the word. It is foreign, it does not belong. And that's exactly why it's valuable. Its trajectory is mathematics, cold, predictable, a curve mapped by gravity alone. But its fate, that's chaos. That's what scientists are watching. That's what makes it terrifying. If Jupiter's gravity disrupts it, we learn something fundamental about how these ancient bodies hold together. We learn about interstellar object stability, density, cohesion. We learn what forces these travelers can withstand after eons of exposure. If it passes safely, we get something else. A chance to track its path out of the solar system. A rare opportunity to observe how hyperbolic visitors exit our gravitational dominion, and maybe to prepare for the next. And there will be a next. 3I/ATLS is a signpost, a reminder that our solar system is not isolated, that it's part of a much larger galactic neighborhood, and sometimes that neighborhood sends visitors, not with intent, not with purpose, but with meaning. Once this object clears Jupiter, that's it. It will head into the dark, drifting beyond the heliopause, beyond the planets, beyond the orbit of Voyager, headed for open space, back into the great silence, and we'll be left with what we gathered: data, spectra, chemical breakdowns, a trail of numbers and graphs and signatures. But that's enough, because those numbers will speak. They'll speak for decades. They'll feed new models, refine theories, confirm or challenge what we believe about the galaxy. They'll whisper truths from another world, long after the comet itself has vanished. That's the legacy of 3I/ATLS. Not its brightness, not its trajectory, but its message. A brief visit, a one-way pass, a glimpse of the unknown, and we caught it. We'll be watching as it rounds the sun. We'll be waiting as it approaches Jupiter, and we'll be listening closely, very closely, as it leaves, because once it's gone for good. But the questions it raises, those are just beginning. If this kind of cosmic storytelling matters to you, if you want to stay updated on the real discoveries, the rare encounters, and the deep space moments that might change everything, go ahead and like the video, share it, drop a comment, subscribe so you don't miss what comes next. Because out here, in the cold vastness of space, the story is never really over. The most important part isn't the moment it arrives, it's what we do with the moment before it leaves. 3I/ATLS is that moment. A streak of cold, ancient dust that doesn't care about our excitement, our instruments, our questions. It has no mission, no objective. It's not here for us, but we're here because of it. Because we have questions. Because we've always had questions. And because something like this doesn't happen twice. We're talking about a piece of raw, untouched galactic matter that was forged under conditions we can't replicate. Not in a lab, not in a probe, not in a dream. The kind of conditions that only exist in the early stages of a star's birth, when gravity, chaos, and time slam together to create matter from nothing. That's what's flying through our solar system right now. Not just a ball of ice, not just a streaking comet, but a memory. A memory of a system that isn't ours, of stars we've never seen, of forces older than the Earth itself. And when 3I/ATLS passed Mars, that memory became something we could measure, record, analyze, decode. The spacecraft circling the red planet didn't just watch it pass, they captured a moment in time. They tracked its outgassing. They caught its spectral emissions. They helped us see what we were dealing with. That moment was the beginning of something we may not fully understand for years, maybe decades. Because this comet doesn't just teach us about itself, it teaches us what we don't know. It exposes the blind spots. For all our satellites, all our telescopes, all our calculations, we were never expecting this. Interstellar objects don't announce themselves. They don't come with instructions or a flight plan. They show up. They change everything, and then they're gone. Which brings us back to what's next. As it races toward perihelion, the closest point to the sun, the stakes skyrocket. That's when the sunlight becomes brutal, when the ice starts to boil, when the comet's behavior can shift in seconds. And that's when scientists start sweating, because perihelion is where fragile things come to break. Some comets survive it, many don't, and with 3I/ATLS, no one's sure what to expect. If it holds together, it becomes a laboratory, a living case study of how alien matter reacts to solar radiation. It could erupt with unfamiliar gases, show signs of chemical structures we've never catalogued, reveal molecules that don't form in the cold of our own Oort cloud. If it doesn't hold together, it becomes a tragedy, a fragmented shell, a lost opportunity, and we won't get another chance. That's the risk, that's the pressure. That's why every observatory worth its salt will be tracking this thing relentlessly over the next few months. And then there's Jupiter. Jupiter, the hammer of the solar system. The planet that broke Comet Shoemaker-Levy 9 into a dozen fiery shards. The gas giant that plays bouncer at the edge of our planetary neighborhood. When 3I/ATLS enters Jupiter's sphere of influence in March 2026, all bets are off. That's not melodrama. That's orbital mechanics. If the trajectory shifts, just slightly, it could put the comet on a crash course. Not with Jupiter itself, but with tidal forces strong enough to rip it apart from the inside. And if that happens, we learn what it's made of, literally, not just composition, but structure, density, porosity, how it reacts under pressure, whether it's a tightly bound nucleus or a loose pile of interstellar rubble, and if it doesn't break apart, if it weathers the pull and sails right past. That's a different kind of data. That tells us this object is stronger than we thought, more coherent, more evolved. That tells us something about where it came from, about what kind of system forged it. That's the thing, this isn't just about a comet, it's about the system that launched it, because comets don't just escape randomly. For something to be ejected from another star system at this speed, with this trajectory, with this level of precision, it means a massive gravitational event had to occur. Maybe a giant planet, maybe a dying star, maybe a passing stellar neighbor disrupted everything. Whatever it was violent, cataclysmic. The kind of event that throws planets into stars and shatters moon systems. And 3I/ATLS is the survivor of that chaos. It's the only part that made it out. So yes, it's just a comet, but it's also a message in a bottle, a snapshot of conditions in a solar system we'll never visit, a system that may no longer exist, and it's passing through our. Which is why the JUICE spacecraft matters so much. It wasn't built for this. It was designed to study Jupiter's icy moons, Europa, Ganymede, Callista. But fate, or maybe good planning, put it in the perfect position to do something extraordinary. Between November 2nd and 25th, 2025, JUICE will get a rare chance to pivot its instruments toward the comet. It might not get close, but it'll be close enough to gather readings, spectra, molecular data, chemical emissions, things you can't get from Earth. And if we're lucky, if the geometry lines up, if the timing holds, JUICE could be the key to unlocking the whole mystery. What kind of ices are in that comet? What kind of molecules? Do they match anything we've seen in our own solar system, or are they something else entirely? We don't know, not yet, but we're about to find out. Because when the sun hits 3I/ATLS, it's going to wake up, and when Jupiter pulls on it, we'll see what it's really made of. And when it slips beyond our reach, everything we've gathered will be the only record we'll ever have. This is the reality of interstellar visitors. They don't stay, they don't wait, they don't give second chances, and that's why this moment matters. Because once this comet is gone, once it clears Jupiter and heads out of the solar system, it enters true deep space. Not just the outer planets, not just beyond Pluto, but beyond the heliosphere, into the space between the stars. The void that stretches between us and the rest of the galaxy. And it won't be coming back. Not in 1,000 years, not in 1,000,000, not ever. It's gone. And the only part of it that remains will be the data, the signatures, the molecules we caught on our instruments, the readings stored on servers, the models updated with its presence. That's it. That's why this matters. Because these objects are more than scientific anomalies. They're part of the galactic exchange. They're the connective tissue between star systems, the natural carriers of information, the silent emissaries of other worlds. And right now, we're lucky enough to have one pass through our sky. So don't miss the point. Don't let the headlines fade. Don't let the opportunity pass without appreciating what we've captured. Because this isn't fiction, this isn't theory, this is happening, right now. And in the end, we'll look back on 3I/ATLS, not as a comet, not as a threat, not even as a mystery, but as a moment. A moment when the universe handed us a clue, a sliver of something bigger, and for once we were ready. It's not just science anymore, it's history in motion. Because years from now, when future astronomers scroll through mission logs and dig through data archives, they'll stop at a timestamp, a sliver of 2025, a handful of readings from 2026, and they'll realize this was the moment. This was when we caught a messenger from beyond. Not theory, not speculation, but a hard, fast-moving truth from another system entirely. A comet that slipped into our solar backyard and dared us to pay attention. And we did. From Mars orbit, from ground-based telescopes, from spacecraft hurtling through the outer solar system, we pointed everything we had at it, because we understood what was at stake. This isn't just about planetary science. This is bigger. This is about where we come from, and whether we're alone in it. Because every piece of data that comes off 3I/ATLS might point to processes that don't exist in our corner of the cosmos. What if it carries compounds we've never seen? What if it shows isotopic ratios that don't match anything in our planetary disk? What if the chemistry inside that comet is so alien, so off the charts different? It forces us to rewrite how solar systems form. That's not a stretch. That's what this kind of object can do. Because if you're holding a rock formed in the gravity of another star, that rock tells you about that star, about the planets that formed around it, about the chemistry that existed when it was young. That's information we can't get anywhere else. No telescope can resolve surface-level detail on a planet circling Alpha Centauri, but a chunk of matter that escaped such a system, that made it all the way here. That's our proxy, our sample, our window into somewhere else, and it's only here for a moment. That's what's so brutal about all of this. The fleeting nature of it, the pressure to make every second count. Because once 3I/ATLS rounds the sun, its speed only increases, its outbound trajectory tightens, gravity takes over, and then it's gone. It leaves no trail, no orbit to trace, no reason to ever return. It will be a ghost, but we'll still be here, trying to decode what it left behind. And even as we look ahead to Jupiter's role in this unfolding story, we can't forget how unlikely this entire encounter is. This isn't the result of a long campaign, or a targeted mission. This is cosmic luck. This is celestial alignment, and it's a test of whether we're ready to rise to the moment. You only get one shot at an interstellar object like this. One window to collect, analyze, and interpret. We're not sending probes to it. We're not landing on it. We don't have time for that. All we have is a limited set of instruments, a rapidly moving target, and a race against distance, light, and time. But even that is enough, if we act fast, and we act together. The global coordination surrounding 3I/ATLS is one of the quiet triumphs of this story. Multiple observatories, dozens of teams from different countries, different backgrounds, all racing to catch this thing as it flies overhead. No politics, no delays, just the shared understanding that this object might hold answers none of us have. It's a reminder that the cosmos doesn't care about borders. And when something like 3I/ATLS shows up, you don't argue, you observe, you record, you learn. Because in that frozen shell of ice and dust is a record of time we've never touched, atoms forged in places we've never seen, and processes shaped by conditions we may never experience again. And once it's gone, the opportunity closes. It's like watching a message burn as you read it. Every second matters. Jupiter's influence will be the final test. If 3I/ATLS survives that gravitational pull, it leaves stronger than it arrived. If it crumbles, then we learn how fragile interstellar bodies really are. Either way, it's valuable. Either way, we're going to learn something we didn't know yesterday. And in science, that's the whole point. Not just to know more, but to know differently, to change how we see the universe, to shift the framework. So when that moment comes, when the comet brushes past Jupiter's invisible grip, we'll be watching, waiting, recording everything, because it won't happen again. Not with 3I/ATL, not with anything like it anytime soon. That's why you're here. That's why you're still listening. Because you understand that these moments, rare, fleeting, unrepeatable, are what drive human discovery, what drive wonder, what remind us that space is not just out there but active, moving, changing, and sometimes, just sometimes, it reaches out to us. So if this matters to you, if you want to be part of the next discovery, the next rare visitor, the next cosmic encounter, stick with us. Like the video, share it with someone curious, leave your thoughts below, and subscribe. Because the story doesn't end with 3I/AT, it starts there.